Where does bell work? Determine the correct description of the shape of the data shown. So this one, it's kind of got this shape to it right here. Now that also means that if we were to look a little bit deeper in here, you could see that the middle is right along this line, which means we are looking at the median. Now, if we can compare the mean with the median, then we can make a more academic conclusion here. But the median and the mean are going to be pretty much right in the same spot, so the mean will be right here, pretty much right here as well. Now, another way you could look at this is that if you were to cut this information in half, like this, see if I can, that's better. Then you can see that it's the same on the left as it is on the right, which means that we're looking at something that is symmetric here. So it's kind of like the shape of the data has just been reflected over this, we would call that the line of reflection, but the mean being pretty much equivalent to the median makes this a symmetric relationship. If we're positively skewed, remember that means that the mean would be to the right of the median. If it's negatively skewed, then the mean would be to the left. But they're in the same spot, so it's symmetric. Okay, there's our 4 objectives today. We got I can determine the strength of graphed relationships. I can find the correlation coefficient of data. Actually, your calculator will. I can write equations in slope-intercept form for data to create a line of best fit. And then I can use the line of best fit to predict values. So take a minute, copy this down, then we'll get started. Now, just so you guys understand, this lesson that we're going over today it's fairly important, even though we're going to be using the calculator to do some of the stuff. As you know, I don't really say a lot of the lessons we go over are important. In fact, most of them are pretty worthless, because telling someone, hey, graph this exponential equation, it's not something you do every day, which is why if you went home and asked your parents, please help me to graph this exponential equation, they'd be like, look it up online, which you could still do. But this stuff is how we actually manipulate and control other people with information, and with information they don't usually understand. That is what we call cunningness. So people that are cunning usually have a little bit more information than you do, at least a little bit more information, and that's what this is. We're going to hopefully help you to not be tricked by statistical data, which comes in this format. We'll explain why sometimes it is manipulative as well. Now, just to start off here, on the assignment, you're going to see problems like this, and what they're going to do is they're going to give you graphs like these, and you got 2 things that you have to determine. First, you have to determine if the relationship between the x values and y values has any type of correlation. So you have, for example, a perfect correlation, strong correlation, weak correlation, and then it is possible to have no correlation as well. Now that's the first thing that we look at is it perfect, strong, or weak, or maybe even no correlation? And then second of all, we would look at maybe it's a positive or a negative correlation. Now we can see positive means that if we were to look at this as a line, that just goes up from left to right. So it has, in other words, a positive slope. If it were negative, it would go down from left to right, which we know already is a negative slope. So positive and negative are things that we've seen before. Perfect, strong, and weak, and no correlation are things that are fairly new to us. So perfect is where the points all are pretty much on the same line, and we're looking at straight lines for this specific unit. So for example, if I were to look at this perfect positive correlation right here, if I wanted to, I could say, look, I can make a line to connect the points like this, and all the points are on the line, even though my line isn't perfect, but all the points would be on an exact line like this. Now that makes the equation, writing the equation for the line, pretty easy. But sometimes you'll see a relationship like this one right here, or this one. Now in 8th grade, what we did is we said, you know what, you draw your own line right here, And you can even put an arrow on it if you'd like. But if you do, then we just eyeballed that, meaning we didn't actually figure out if this was an exact equation or an exact line. But you can then figure out what your y-intercept is and then your slope is. Now the slope, again, going down from left to right is why it's negative. But you can see the line that I've drawn where the points are not exactly on line, but pretty close, relatively close. That is why we make, or we would call this a strong relationship. Now just so you understand, if I wanted to, I could manipulate the scale on this so that the points would appear even closer to the line, which is why it's very difficult to look at stuff like this and believe everything that you're told. In fact, I'm encouraging you now not to believe everything you're told when you see information like this. And another reason for that is because once math people draw the line here, or statisticians will draw the line, they ignore the points. Meaning, once you have this line, pretty much this point right here, it never existed, or this one, or this one, or this one. All of them. None of them would exist. Okay? But the way that we're doing it, as long as the points are close to the line, we would call this strong. If they're exactly on the line, then it's perfect. And then we have weakness over here. Now you can see that we kind of have a blank area here and then a blank area there. And so this line would, technically it's going up again. So I'm going to look at the positive one here. We'll put an arrow on the end now that it matters. But you can see that the points, while they're showing that there's an upwards pattern from left to right, making it positive, the points aren't exactly, or they're not even really close to the line. Not all of them anyways. You have some points that are fairly far away from this line right here, making it a weak relationship between whatever the x and y's are. So, to expand on this, just so you understand, the x and y's would have some kind of labels on here. And if you were to do this, I don't really care about it, but math people, like if you were to do this with other math teachers and you were to take this in and be like, look at this, what I've done, math teachers, they get really geeked out about this kind of stuff. But one thing that math teachers like to see, and I don't know why they like it so much, but what they'll say is, we're going to compare a person's, maybe their height to their shoe size right here. And then you get this upwards relationship. It would look something like this, or at least we would expect it to. And if you were to do that and show it to a math teacher, they'd be like, holy crap, this is the greatest thing I've ever seen. Please let me have it so that I can frame it and put it on my wall. And it's hard to think that people are that nerdy, but they exist. They're out there. So I'm just not one of them because I don't really care that much. And this is highly manipulative. So down here at the bottom, of course, there's not really any blank areas. You got this one right here, but I can't really say that there's a pattern going up or down. And this is where you got to be careful, because what they'll do is they're going to say something like, look at this relationship. It's going from left to right directly straight in this horizontal line like this. Now, if you can see that there's not really a pattern here, so anyone that were to tell you that there is a pattern is probably lying and trying to get you to believe crap. But once again, the problem is that they're not actually going to show you the dots on this graph. They're just going to show you the line. And so there may not be a relationship. For example, what you could compare is maybe shoe size to test scores. There generally is no relationship to shoe size and test scores. So you end up with a no correlation between those two types of labels or comparisons. All right, so be careful, because people will do this to you. We don't want you to use it on other people as well. But just so you understand, here at school, we do this all the time. Now, the other thing you'll notice is that what we can do, well, you probably wouldn't notice this because you've never seen it, but what we can do as math people is we can take a graph like this one right here, and it doesn't matter if it's positive or negative, but let's say that I really badly wanted to show a stronger relationship than this one. Okay, so what I would do is I would take this data and be like, I don't really like that data, so then I would maybe do something with you guys in order to get you to do it better, so that it represents something more like this. And then if I can get you to do something, and then I can train you guys even better, then we can get something like this. Now, The problem with what I just said is that I am training you. We train dogs, not people. So anyone that's like, I got to train you to do this thing, just be careful. We train dogs, not people. So just be careful, all right? Because in school, we do this all the time where it's like, we got this data, we'd really like it to be like this. So we take this data that we start with, and then we train you, and then we train you even more. The other thing about this type of data, which you'll see, again, I guess you wouldn't see it, but what they'll do is they'll say, look at this, look at this strong positive data right here, this one right here. And they'll say, actually, you know what, that's the data that we got right here, this green line. And if you ever do something like that to other people, we know that you will have a great career as a politician because you have just lied. The other thing that you may see is something like this. And if we see you doing that kind of crap, now we know what party you belong to as well. So be careful. Statistics like this, there you got lies, you got dang lies, and you got statistics. Welcome to statistics. Now on the assignment, of course, all we've got to do is make the conclusions on these. So if I were to look at a graph like this, and I'm going to start with if it's perfect, strong, weak, or no correlation. But you could start with the direction it's going in. I'm going to start with the strength of it, though. So I can see that all these points on this graph are pretty much all in a row. Okay, there's none that are even off the line. So if I were to draw the line for this, I would expect something like this one right here. So first off, I would say that all the points are exactly on this blue line that I've drawn, even though I don't know that that's the exact line. So I'm going to call this a perfect relationship or correlation, perfect. Okay, so that is the strength of the graph. Next, I need to say which direction it's going in, and I see that it's going downwards from left to right, which makes it a negative slope. Those are the two classifications we need for these, and then we'll just write in there. It's a perfect negative correlation between whatever the data is. They didn't give us any labels here. We don't really need them, but that's how we would classify this. So on the assignment, they're going to have all 7 classifications. You got to choose which one it is. Now I'm just going to emphasize this again because people look at this stuff and they just believe everything that's told to them, especially when it comes to math. If I wanted to, just so you understand, I could change this scale to make this really steep downwards if I wanted to. If I wanted to, I could make it really, really horizontal, pretty horizontal there, with just some small math tricks. That's all it would take. And then I could tell people anything that I want and get them to believe anything I want. You gotta be careful. So this one, determine again, we're going to determine the type of correlation we have. I'm going to start with the strength of the correlation. Now I see some empty space here and here, so if I were to draw a line, not that it has to be exact, but I would expect something like this one. So I can see that the lows are getting higher and the highs are getting higher. So this means it's going up from left to right. But that line that I've drawn, we got points that are fairly far away from that line that I've drawn, which means that right here I would expect this one to be a weak relationship. Nothing really close to this line. It is weak, and I see that it is going up from left to right. So the direction, I have the strength. Now I've got direction, which is now positive because it is going up from left to right. So that is the type of correlation that we have there. So what type of correlation do we see here? I don't really see any empty space, right? So if I were expecting, which I kind of was, if I were to see a blank area there and maybe a blank area here, all right, that looks pretty positive, but the way that it is, this one has no relationship, no correlation on this. Okay, so this is no correlation, but if I were the person that had this data and I was like, I really wanted it to show something that was positive, maybe even positive weak. What I can do, because I have all the data, is I can take this information here and just be like, you know what, we don't need that information right there because and I can make up some reason, right? Be like, this data doesn't make sense, and so we just kind of ignored that data right there. And then I could look at these spots right here and be like, you know what, we don't really need that information either. What I've done is I've just taken no correlation and made a positive weak correlation. And then, once again, I could draw a line saying, look at this positive relationship right here, and since no one asks any questions of statisticians and people don't know any math, they'd be like, thank you for that information, I believe you and everything else that you say. Which is very dangerous to let people have that much control over you, because that is how I would make a positive weak relationship. If I wanted to, I could also just adjust these just a little bit, and now what I've made is a negative weak relationship. Why would I do that? Because I would want people to believe a specific thing about whatever it is that I'm doing. But again, in actuality, because I'm not showing you all the data, I have all these points underneath these white boxes that I just put in there. They're there, but I get to justify why I'm not using them. And people just, since they don't ask any questions, they don't understand, and so they believe everything that's told to them, even though, in fact, there's no correlation at all. So I just can't emphasize this enough. This is one of those lessons where you should be using all the time, because people are constantly saying, hey, look at these relationships that are occurring in real life, even though maybe there is none. Maybe it's not even positive or negative. Who knows? But if you don't understand this stuff, you open yourself up to be highly controlled by other people, which should worry you, because that is what we call a slave. All right, how about this correlation right here? So once again, I'm just going to draw the line just so we can get an idea of what we're looking at. So I would expect some line like this one. And yes, I'm just eyeballing it. We're not actually finding the exact equation here. But from this line, I can see that the dots or the points are pretty close to this blue line that I've drawn, which means that I'm looking at a strong relation. If it's not perfect, definitely is not weak, because the points aren't very far away from that blue line. And by the way, if I were to look at this as a math person, I could easily declare this as weak. Maybe I would want to show it as weak, and I want people to believe that it is weak. Why can I say that this is weak? Because I'd say, well, the scale is large numbers, so actually this point right here is actually 100 away from the blue line, which makes it weak. Even though technically it doesn't under this information that we have. So it is strong, but be careful, because some people will say it's a weak relationship. I definitely wouldn't say it's perfect, but again, I could probably manipulate the scale in order to make it look as though it were perfect. So it is strong. I see it going down from left to right, which means this is also a negative relationship. So it's a strong negative relationship, or more specifically for this lesson, correlation. Now, like I said before, what will happen is when people make this information, sometimes what they'll do is they'll take the points that are on there and they'll take them off. Okay, so really all you would be looking at is this blue line right here. Now again, what this does is it creates a pattern, whether it's a pattern of behavior, which should worry you, but no one really knows or understands it, or it just creates a way for me to predict the future based on this information. So what I would do is I would look at this and say, anyone who's in this area, I would follow up. Again, I would ignore the points. I would go to the blue line, and then I would say that would get this y value. This x gives us this y. That's an x. X gives us a y, which technically is false. It's just what we would expect, something in that range, even though there's this value right here, which pretty much has the same x value and pretty much has the same y value, but it's not exact. And that's the part that should worry you, is it is not exact. And pretty much everything in math is supposed to be exact. So this line, which we also call a line of best fit, is also a predictive line. It's a line that we can then use to predict the future. So that line is a predictive line, a line that allows me to predict the future based on the information that we have. I don't care if it's strong or weak or perfect. I can then use that line to predict something that's going to happen in the future. Or I can say, you know what, you belong in this area, so I would predict that you would also belong in this area. See what I'm saying? Now, it can be handy, if you're maybe in something like sports. I would never encourage anyone to gamble, but people do it. You could use it, perhaps, this type of idea in the stock market as well. But if I were to look at this first graph right here, if I were to put the line, and I'm just eyeballing it again, something like this one, this is a strong positive relationship. All the points are pretty close to the line, and it's going up from left to right. What we need to do now is we're going to call this linear regression, which is also known as the line of best fit, which in the past we called the slope-intercept form of a line. That's pretty much 3 different names for the same exact thing. So if you thought this was manipulative, you should understand by now, after all the math that you've been through, whether you were paying attention or not, by the way, that math people are highly manipulative. Because what we do is once you get slope-intercept form down, if you pay attention, then we'll say something like, we're going to use the line of best fit, even though it's the slope-intercept form of a line. And then once you get that down, then we get to say linear regression. And so we're using pretty much 3 different phrases for the exact same thing. So slope-intercept form, that's the form that we're going to see these in. The form that we looked at with slope-intercept form was y equals mx plus b, where m was the slope, and then the plus b part, that's the y-intercept. So the y-intercept can be found by looking at the graph, which we're not going to be doing, but you could look at the graph and just see where the line goes through the y-axis. This would be the y-intercept, or the b value, and then the slope was found by seeing how far up and then to the right it goes. Or in this other graph, this one, again, that's approximately the line of best fit. This one would have a y-intercept here, and then the line goes down and then to the right. Okay, so up and to the right is positive slope, down and to the right is negative slope. So another thing to be careful about with this information is, let's use this first graph right here. Okay, so if I have this information from a set of data, what could have happened, and again, it's not even showing this, but what can happen sometimes is you can have a point right here, and math people, statisticians, people that like stats, they'll look at this point and be like, it doesn't fit the pattern of the data, the dots. They're going to look at the dots and they're going to be like, what the crap is going on with this dot? And what they'll do is they're just going to simply erase it and ignore it like it never happened. Now, if that didn't sound extraordinarily manipulative, it was meant to. So if you don't understand, there could be other points on the very outside of this graph. Maybe even like, there could be one over here. And they'll be like, we're just going to ignore that point because it's so far out there. It's called an outlier. All right, the slope of the line of best fit. So it's just the slope of the line. We don't really need the best fit part, but it's a statistic, so we're going to call it that. Now for axes, what you have is you have the vertical axis, which is the y-axis. And then you're going to have a horizontal axis like this one, which is the x-axis. Okay, something like these. Now, the slope is the steepness of the line. We don't even care about that for these problems. All we need to do is say the label of y divided by the label of x. So just like we've seen in the past, what we're going to do is we're going to say you're going to take the y label and divide it by the x label. That's it. If you can understand that, then you should be able to do these pretty easily. We are not calculating anything on these first problems. All we're doing, just like we were on the last ones, can you look at it and determine the strength of the relationship or correlation, and then can you determine the direction? This one, all we're asking you to do, we don't care about what's on the graph or if there is a correlation. All we're asking you to do is look at the y-axis label and then look at the x-axis label, put the y-axis label over the x-axis label. That's division. So it's y's per x's, kind of like miles per hour or something like that. So for this one, based on the graph, what does the slope of the line represent? The slope of this line is positive. I don't care. Not for this problem. All I got to do is say what it represents. This will be multiple choice on the assignment. Not that it should matter. So once again, I'm going to write it as a fraction. We know that it should always be y's over x's for these. So I'm going to start with the y's. And I don't care about that. I don't even care about the numbers on the scale for either one. All I care about is the label. So the label for my y's is height. So that's the height, h, g, h, t. We can put centimeters there. That's the height in centimeters. And then all I need to see is the label for the x-axis, which is femur length. Femur length. And this femur length is also in centimeters. Okay, so that's how it would look like as a fraction, but on the assignment it won't look like a fraction like this because it's kind of like that per thing, like mile per hour. So we're going to say that this one, it's the height, or the person's height, and I'm not going to say in centimeters, height over femur length. And I may have misspelled those, but I also don't care so much. That's one you got to choose. Again, I think there are going to be 4 options there. It's height over femur. One of the mistakes that we see on a problem like this one is where students just get them mixed up. They'll do the x's over the y's, but slope is always y's over x's, which we have seen in the past. This is not meant to be difficult. The real question is here is just look at the graph. That's it. So this one, same idea. I don't care that the line's going down. I don't care how many dots there are or what the pattern is. We just want to know what the slope of the line will represent. Now it is a negative slope, and we'd call that, looks like a strong relationship right there. So I'm gonna write it first as a fraction with my y values on top and my x, well, not values, but labels on the bottom here. So the y label is hot cocoa sold, so that'll be my numerator. And then the x-axis, which is in temperature degrees Fahrenheit. Okay, so we'll just write that in as our denominator right there. And that's in degrees Fahrenheit. Now, if you think about this, which not many people do because it's statistics and it's a graph and it's math, there's many reasons why people don't think about this crap. But this would make sense, okay, because this is the high temperature. If the high is 50, that's degrees Fahrenheit. The higher the temperature, the less people would want hot chocolate, right? Maybe they would want cold chocolate milk, okay? And then maybe, you could get kind of crossing patterns there. Maybe people want it all the time. But again, the thing you got to be careful about is when people are like, this is not a negative relationship, it's going up. Because people that tell you that are clearly liars. You got to be careful about those people. Now, I showed this as a fraction, which is nice. But we would want to show this in words as well. So if we got the hot cocos sold over, because that's the fraction, that's an over the high temperature. Boom, that's the one we would look for. Of course, they may have more information here like degrees Fahrenheit, but that's as much writing as I want to do. All right, now this part. So we're actually going to write, we're not going to guess like we did in 8th grade. We're not going to look at the graph and just be like, we're going to eyeball that sucker, because eyeballing was not very exact. In math, we should have very exact values. Now, the good news is in 9th grade, which we are in, we're not actually going to force you to calculate these on your own, which is a very long process, and it's very tedious, and in my opinion, it sucks. But there's math nerds out there that love it a lot. Now, we're going to make the calculator do the work for us, okay? So this is what we're going to do first, is we have to make the diagnostic on. Why does diagnostic on have to be there? I don't know. And I also don't care. I just know that we need it. So we've got to go to diagnostic on. Okay, so we're going to push second, and that's the number 0. Now you'll notice on the calculator, you got second 0 just above the 0 in blue, because we pushed the second blue button. It says catalog. That's going to give us all of the functions of the calculator, all of them. But it's going to do it in alphabetical order. So second O, or 0 rather, is the catalog. I'm going to push x to the power of 1 button, which is 4 buttons down from the top left, or 5. It's 3 buttons down from the second button. So the reason I'm pushing that button is because it's got the D on there, and I need diagnostic on. So when I push D, it's going to give me the menu for the Ds. I'm looking for this diagnostic on. And again, this is all in alphabetical order. So you can just scroll down until you get to diagnostic on, which would be 10 down buttons to get there. Okay, so you push second, the number 0, x to the power 1 button, which is on the left side of the calculator, and you're just going to push down 10 times. Once you get there, then you'll see that the arrow is on diagnostic on. If you went down to, if you see this dim parentheses, dimensions parentheses, you went down too far. What we need is diagnostic on. So I'm going to push enter, enter. Now on my screen, it'll say something like diagnostic on, thank you very much, good job. I don't know what it's going to say, something like that, okay? But I need diagnostic on. Once I've done this, I don't have to worry about it ever again. So as long as we got diagnostic on the calculator, it will do the work for you. If you don't turn it on, though, like we just did, the values that the calculator is going to give you are going to be off. So you have to turn the diagnostic on first. Now that we have diagnostic on, what we can do is we can enter the table, and then this is called linreg, which is going to give us the values of the slope and the y-intercept for our for the information. Now in the table. So you push stat enter, which we've done before. If you push stat, this screen is going to pull up and it's got edit, calc, test. We've got to edit the lists. So you push edit, then you push enter. You push stat, and then you push enter. And that will give you a list, some kind of screen that looks like this one right here. It can show up to 3 lists, but you could actually go further to the right here if you wanted more lists. So we're going to enter the first column into L1. That's our first list, or list 1. That is for our x values. And put this in color code there. That's our x values. From a table. You don't have to worry about the table. They're going to give us a table of values. That means list 1 is going to be our x values. List 2 then, in a table, we're only looking at 2 variables. That has to be our y values then. So when you find your y values in the table, which they're going to give us, you're just going to enter those values into this table. Remembering to, if you need to clear it, you go up to L1, you push clear, then it empties this out. Or you can just type over the values that are given in there. After each entry, you've got to push enter to get to the next one and the next one and the next one. You need to make sure these line up because there should be the same number of x values as y values in each of the tables they give us. But this is just to enter the table. Once we get that, then we need the slope and the y-intercept. That's called linear regression, which it shows up here. They're going to give us the a and b value, though they won't give us the equation directly. So we're going to have to write the equation ourselves. So I would push stat. Okay, so stat is 2 buttons to the right of alpha here towards the top. I push stat, and then it's going to pull up this menu. It's going to start in edit, just like this one shows. It's going to show edit right here. We don't want that menu. We want the calc menu, so I've got to push over. Then I've got the calculation menu. I'm telling the calculator, please find this for me. I want the linear regression, ax plus b. So I'm going to push 4. You can just scroll down and go to 4 and push enter. It doesn't matter. And then from there, whatever the screen is, and I forget what it is, just push enter, 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 enter. Boom, that's it. Okay, once we get that information in there, the calculator will give us all the information we need. We don't have to calculate any of this crap by hand. Other than typing it into the calculator. But I know you guys are good at texting, so this should be pretty easy for you. So here is a list of values. We got a homework grade and we got a test grade. So the first thing I'm going to do, since we've already turned the diagnostics on, I don't have to worry about doing that again, though you're welcome to do it. So I'm going to push stat. Now that's going to pull up that menu. I want to edit the lists so that I can put these values into my lists. I got a homework grade, and then we got test grade. So I'm going to push enter. And then I've got some values to put in here. I got to clear some stuff though. So I'm ready to put my list in. Now for the screen, right? my x values, I'm going to put this in as list 1. My y values, I'm going to put this into list 2. So I'm in the table mode. I'm not worried about this part yet. We're going to get there. But I push 75, I've cleared mine by the way, but I push 75 enter, 82 enter, 89 enter, 90 enter, 78 enter, 60 enter, 76 enter, 50 enter. And that will complete my list 1. Now I got to be careful, at least for me. When I did it with one of the classes, I pushed 76, 50, so I pushed the 76 and the 50 on the same line. If you do that, I didn't notice it until I finished this line right here, and I didn't see an x value for this y value, and I saw that I mistyped this one, so I had to go back and fix it, which you can do. You don't have to clear the whole list, you just got to go in and type 76, enter, then 50, enter, then you'll see that they're lined up. So that's one way you can find your mistakes, some mistakes, is if these are not lined up, then usually you may have double typed in values up here. Now, when we find the linear regression information for this equation, if you don't get the same values, which you may not, then it probably is because of one of two reasons. Maybe you mistyped one of these values in, which I do from time to time. On the other hand, though, what you could find is that you have not turned your diagnostics on, which you would need to do. Go back a few slides. So I've got my lists in. Now I'm ready for linreg. That's linear regression. So I push stat. I go over to 4. That you'll see that it shows linreg ax plus b. That's the option that I want. Now whatever it shows there should show. Okay, so this is what my screen is showing right here. This is from just pushing stat over 4. Boom, that's what I see right there. And for my X list, since my homework grades there, the X values is in list 1. I put in list 1 right there. It should already say list 1. And then my Y list is my list 2. Now, if you wanted to use more of a list, you could. But that's all I need right there is list 1 and list 2. These are going to be blank, which is why we just push enter, 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 enter. And that's going to, at the bottom there, it says calculate. So once I calculate, it's going to give me the values that I need for my linear regression equation. All right, that's the information that we need. Now, once we have this information, which we will be using for the equation, it has all the information we need. It has the slope and the y-intercept. Now that we have this information, just like other math people would do, we'll pretty much ignore all of the data that produced this information. But what is the equation? Because we're going to need the equation for the assignment. Well, the equation would be in slope-intercept form, but right now, instead of it showing as y equals mx plus b, it is now showing as y equals ax plus b. Still a b value, I guess. But we have an a value and we have a b value, which were given in the calculator. So it says to round all coefficients to the nearest hundredth. That's talking about the a, which is this value. The nearest hundredth is 2 decimal places. The 6 is going to add 1 to the 9. And so instead of an a value here, I'm going to replace that with the number I get. 9 plus 1 is 0, but would carry the 1 to the 7. 7 plus 1 is 8, so I get 0.80x. You don't really need that second 0. And then the b value that it gave us was this one right here. So I'm going to round it to the nearest hundredth again. The 1 is just going to keep the 8 and 8. And that's positive, so I'll keep the plus sign, by the way. But now it is going to be 12.78. This right here is my linear regression equation, which is going to be one of the boxes. The next box is the next question, which says, use this equation to find the projected test grade to the nearest integer for a student with a homework grade of 39. So on this one, it says we're looking at a homework grade of 39. If we were to look back at the table, the x values are the homework grades. So we're looking at an x value here, which will be important to know because since it's an x value, I'm going to take the x in the equation and simply replace it with that score of 39. Now notice what we're doing is we have an equation to represent the information of students' homework scores to test scores or test grades. So We're predicting, though, if someone got a 39 on the homework, then we can then predict what kind of test grade they will get. Now, does this mean it will always be true? No. But if people work like people do, like dogs or robots, then we should be able to make this prediction because we've then forced people to do what we want to do. Well, to solve this, I just put it directly into the calculator. So I just push 0.80 times 39 plus 12.78. Okay, so my calculator is going to give me this decimal value of 43.98. That would be the test score that I would expect. But it also says to round to the nearest integer, so that would be the ones place value. The 9 is going to add 1 to the 3, and my new y value expected, 3 plus 1 is 4, 44. That would be the test score or test grade that I would expect from someone who has a 39 homework grade. But again, I just can't emphasize this enough, is how manipulative that is, because we don't know anything about this other student. We don't know, maybe they did all the homework or they just didn't care. They did the minimum amount of work. We don't know, so they could score high on the test. But again, it does allow us to make predictions based off of psychological human behaviors, which should worry us a lot. It should worry us especially if we understand anything about what is called MK Ultra. The R value right here. This one is 0.8739480203. Now, the strength is how close it is to either 1 or negative 1. This is fairly close to 1, so this is a strong relationship, is what I would call it. The closer to 0 you get, the weaker it is, like we've seen. But this one would have a strong relationship. And it wouldn't matter if it was negative or positive. Anything close to negative 1 or 1 is considered strong. If it's exactly 1 or negative 1 for your R value, then it's considered perfect. But if it was exactly 0, then there's just no correlation whatsoever. Once you put those two answers into the equation, into the assignment, what it's going to do is it's going to show you the graph, like this one. Of course, we already had a table, but you don't have to do this stuff. The assignment's going to do it for you. I mean, you could graph it if you'd like to, but you can see. Remember the slope that we had? The slope was 0.8. It's practically a 1, which is about that slope right there. So 12.78 y-intercept, which is about right there. And then it's showing, with this line, with this information, we can predict if someone has a 39, they would have a 44 test score, something like this, okay? 39 homework, 44 tests. But here's all these points. And again, this is the thing you got to worry about. Like these 2 points, they're not even on the line. Now, it's strong because they're fairly close to the line, but they're not exactly on the line. So it's like, well, why are we making this prediction? Well, it's usually to manipulate people, because then I could say, look at this line right here, and look how awesome it is, or how bad it is, whatever the narrative is that I want to lead people into. The strength is kind of represented by how close these points are to the line that it gave us. So write the linear regression equation that represents this set of data. So they've given us a table again, round all coefficients to the nearest hundredth. So I'm going to enter the table in, and we're going to put this one. I know we just did a problem, but I'm going to make this my list 1, which will be my x values, and then the new cases will be my second list right here. So to enter this into the calculator, all we got to do is push stat enter. If you wanted to, you could make, because we already have list 1 and list 2 from the last problem, if you want to make this list 3 and list 4, you can. Just when we go to linreg, we got to make sure we enter it in as list 3 and 4. But I'm going to keep this in as list 1 and list 2. So I push stat enter, and then I enter these values, right? So for my list 1, if there's values here, I can clear that out. But I just push 0 enter, 1 enter, 2 enter, 3 enter, 4 enter, and then I get this list for list 1. That's my x values. My y values, that's the new cases, whatever this is. And then I push 757, enter, 719, 682, 705, and 645. I'm going to enter all these in. Now, you'll have to be careful because, at least this is a mistake that I make often. Sometimes I'll enter 2 values into one box, and so I'll see that they're not actually lined up at the bottom. And so you want to be careful about that. So if you have like a 645 here, but not a value here for your list 1, you need to go back and find out where you made some mistakes. There's a lot of numbers to type in as well, so if you find that your answers are not correct on the assignment, either two problems. Maybe you didn't push the diagnostics on, or maybe you misentered a number. But now that we got those into the calculator, I'm ready to find the values that we need for the equation. So I'm going to go to ln reg ax plus b. So that's stat over 4. And so that's the calc function of our stats. And 4 is ln reg ax plus b. Now we got this screen right here, right? Now I have my x list. That's this one. That's my list 1 right there. Years since 1996. That's list 1. So I just want to make sure that shows L1. And then list 2 is my new cases. That's my y values, which is the next line. I just want to make sure that shows L2, which it should. It should come already equipped with that. So once I see that, I push enter, 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 and then it will give us this next slide. All right, so this is the information that it gives me. The screen will always have y equals ax plus b, because that's what we were trying to find with ln reg, ax plus b. A is the slope, and b is the y-intercept. They are different this time because we're using a different set of data. Now at the bottom we have an R value. That's the strength of the relationship between years since 1996 and new cases. I don't really know what this means by new cases, but I know what years since 1996 is. That is really close to -1, so I would say this one is pretty strong. It's a pretty strong relationship right there. Remember, if it's close to -1 or 1, we would consider it strong. If it's exactly 1 or -1, then we would say it's perfect. And anything close to 0 is considered weak, or it gets more weak until you get to 0, which is no correlation at all. Don't worry about R squared, but what we need, at least for this problem, is the A value and the B value. Like I said before, now that we have the information there from the calculator, I don't really need any of the information from the table anymore, other than to maybe check in case I got some values wrong in here, which again means that your diagnostics on hasn't happened yet, or we mistyped some of these values. But we should see something like this. So my equation, it should be y equals ax plus b. A being the slope, and then the plus b. B is still going to be our y-intercept. So they said over here, the A value, which is shown here in the equation, I've just rewritten it over here so I can take that A and replace it with the number they've given us. No need to round this to the nearest hundredth like it says here, because these are in the tenths. So that's -23.8. That's my slope. And then the B value, which is my y-intercept, is showing as positive 749.2. So I take the B and replace it with plus, because it's positive 749.2. That's the equation. That's all we need for the equation. I can put that into the assignment, and then we can answer the second part, which is using this equation, find the projected number of new cases for 2004 rounded to the nearest whole number. So I'll box this in this time, because that is one of our answers. Then I'm going to rewrite it so I can work with it. All right, so there's the equation. Again, this is in the first box, but I got to find out what's the projected number of new cases, whatever this is representing, for the year 2004. Now, it's not good enough to say, well, the year is 2004, so I'm just going to replace X with 2004. Now, it says years since 1996. So how many years since 1996 is 2004? That's the value that we need. So to find that, it's a difference or distance between the values. So I just take the 2 and subtract them. And then I get 8. That's 8 years since 1996, which is clearly a X value. So I'm going to take the X in my equation and replace it with 8. And then I put this into my calculator. And this is my Y value. This Y value is showing as 558.8. But up here it says round to the nearest whole number. So the whole number is the 1's place value, where the 8 is right there. The 8 to the right is going to add 1 to that 8. And so my new y value for the year 2004 would be 559. That's how many new cases there are. So there's a word problem. So I'll make sure to label my answer. That's it. So in the year 2004, we would expect 559 new cases. Is it going to be exactly that based on the information? It could. It could be off by a few. Who knows? Because again, this is a strong relationship. This being very close to -1. Yeah, we would expect the number to be pretty close to this, if not exactly 559. But it's manipulative to say that because we just don't know what's going to happen in the future. Like I said before, once you get that information entered and push enter on the assignment, it's going to give you the graph. It shows a downward slope, which was the negative A value that we had. And so for 8 years since 1996, we would expect there to be 559 new cases. So eight years since 1996, 559 new cases. Of whatever this is. I don't know what it is. Something like that. The other thing I'd point out about this is that there's only 5 points of data in order to make this assumption, which isn't very much. It's not very much. Usually, in order to make these types of conclusions, you want at least maybe 100. And if you can, the more you get, the more accurate the data, which is, again, it's kind of scary once they start using this kind of information on people, which we do all the time in schools. When we say relationships on this, we're talking about a correlation between the x's and the y's. And we say 1 or -1 or 0, we're talking about the r values for these. So we're looking at r values of the data that they give us. We do not have to calculate these on these problems. They're going to give us the r values in the problems. We don't actually have to calculate them, otherwise we'd have to use the calculator for all of them, which we don't want to do. Like I've been saying, anything close to 1 or -1 is considered strong. The closer you get to 0 is a weaker relationship. So you have to be careful on that. But like I said, we're only concerned with the r value. So on a problem like this one, it says we got 4 sets of data. You got data set A, B, C, and D. They've given us A and B values for all 4, and then the r values. Like I said, we don't really care about this other information right here. The only thing we're concerned about when we want to determine strength of relationship is the r values, which we see down here at the bottom. So if it's going to be considered strongest, then we need an r value that's going to be close. Got to be close to either 1 or -1. So I would look down here at the bottom, and I see we always have 0 point something on these. And it appears to me that set A, which has, I'm not even concerned about the hundredths, thousands, or 10,000s place value. You just see 0.9. And I don't really care that's negative either. So these ones are, there's positive, negative, negative. I don't care about negative or positive. I just need something that's close to 1. 0.9 is definitely closer to 1 than 0.8, 0.6, or 0.7. So set A would be the strongest relationship. Whatever we're comparing. I don't even know what we're comparing on this. Doesn't matter. So which one's going to be the weakest? Well, if it's weak, then it has an R value that's going to be pretty close, or the closest, pretty close to 0. So I look down here, and I pretty much am looking for the smallest value overall. I'm not looking for negatives or positives, right? So I look down here, and I see, well, we got a 0.8, 0.6, and 0.7. I don't care about the negatives, but 0.6 is the winner because it's the lowest number right there in the 10th place value. So it appears that data set C would be the weakest relationship between your X's and Y's. That's it. So that's all we got to do. And we went through each objective. We need to be able to determine the strength and direction of graph relationships for data. And then correlation coefficient, that's the R value, which we just use the calculator to do. And then once we get a table of data, we can find slope-intercept form with the A-B thing on the calculator. Again, this is calculator stuff, all generated by the calculator, and then I can use the line of best fit to predict values. But the calculator is going to help us with those as well.